You guys should all see your warm up on your screen, so make sure you go through and add that to your previous 2 warm ups. And we're about to go through them together. Please be ready to answer questions. Sorry, couldn't think of what I was trying to say. I'm going to turn my document camera on real quick so that you guys can see both the warm-up and us writing down the solutions. So let's get this down. Oof, there's a lot of stuff up. Okay, so we need this guy. Come on. Okay, so you guys should see the warm-up, and the document camera is being a little fussy. So we're going to give it a minute. And then we'll get started. So for each picture below, you're supposed to write a function, that matches with the graph. Okay, so I'm going to call on 3 of you to answer this question. Oh man, this document camera. And if for some reason your mic isn't working, I need you to let me know in a remind message so that so that I know what's going on. Man, whenever I teach you guys this class is when this document camera gets fussy. Okay, so for each picture, we're writing a function that matches the graph. So this is our warm up on 9-2-20. And we have an absolute value graph with a vertex at 0, -3. So yesterday we talked about function families. We talked about absolute value graphs. And in your investigation that you should have completed half of yesterday, you should have figured out how to write in these transformations. So Olivia, are you here? Rashani? Abimael? Daisy? Daisy, are you here?
Yeah.
Okay, so I'm trying to write a function, f of x. And I want to write it so that it would look like this graph right here. How would I write that function?
Y equals the line.
Yeah, the absolute value line.
Yeah. -3.
You're gonna have an x in there.
Oh.
Is it shifted left or right at all?
No.
So the original graph is like this, right?
Mm-hmm.
And you're correct. It is not shifted left or right. So we should just have the absolute value of x in there. Okay, we don't need anything inside of the absolute values. But how far did it shift down?
-3.
Yeah, so should I add or subtract 3 from this whole thing?
Subtract.
Very good, subtract 3. Perfect. Okay, so this is a function that could match this absolute value graph. Okay, so the next graph we have looks like this and has a point given at -4, 0. Okay, so let's see who's next. Dakeem, Tyrell, Henry. Henry, I know you're in this meeting. Can you help me out on this one?
Yeah.
So what type of graph is this, first of all? Which function family is it from? Huh?
I don't know. I forgot.
Okay, so yesterday we did a whole sheet where we talked about all the function families. Which one does it look the most like?
Oh, square root function.
Yeah, it's a square root function. So how am I going to write that square root function?
Y equals a squared pi x.
Yeah, the square root of x. And then is this square root function, so this is the original. Is it left, right, up, or down?
It's left.
Yeah, so what do I add underneath this square root?
Negative.
So we actually are going to add 4. When it's in the function, you put the opposite sign.
Okay.
Okay, so plus means you're moving left, minus means you're moving right. Very good, thank you. Okay, and then last function, let me take a look at it. I can only see part of it. Okay, is this quadratic? Draw it in. Oops, I gave it away. Okay, and we've got a vertex at 3, 1. Okay, so let's see who's going to help us out with this one. Katie, can you help me out?
Yep.
Okay, so which function family did this belong to?
The quadratic.
Yes, very good. So I'm going to have y equals, and then how am I going to write this function?
Basically it's x squared, but
Right.
I don't know what the x would be.
But the exponent needs to be, like, we need to put something inside of there, right? So we got to put the square on the outside. And what's going to be inside of here with this x? Did it shift left, right, up, or down?
Right.
Yeah, it shifted right. And so when we shift right, we use the opposite sign. So we're going to use a negative and then a 3 because it shifted 3 units to the right. And then how many units did it shift up or down?
1.
Yeah, and it's 1 up, so we add 1.
Okay.
Okay. We're about to go through our activity from yesterday, so that'll help out with this. But this is your warm-up for Wednesday, September 2nd. Make sure that you have that written down on your warm-up sheet. Okay, let me add somebody into the Teams meeting. Okay. Hello, JP and Regina. Sorry for the delay. So we just completed our warm-up. I will post the video of today's class later so that you guys can catch up to the warm-up, or if you want to take a quick picture of the screen, feel free to do that. I need everybody to get out whatever they were writing their activity on from yesterday, their Desmos, discovering the transformations of quadratic functions. We are going to go back over that today and try to finish it out. So please have whatever you were writing that down on out. Okay, so I'm taking off this warm up. Let's downsize this and pull up Desmos. I think I even have it out from the other day. Awesome. Okay, so this is what we were working on the other day. We drew in one of our functions, and the next step was to draw in another one, okay? And that ended up being the green function that's on my Desmos page right now. And so I want to go through and I want to see what you guys got for each of these pieces. So Lamaro, are you here? Jason. Jason, are you here?
Yo.
All right. So what did you get as the vertex for this particular function?
I remember.
Okay, well, we can look at it and figure it out. So I graphed this function on Desmos. It's the green function on this grid right here. Do you remember what the vertex of a parabola is?
No.
So the vertex of the parabola is either the min or the max, depending on which direction the parabola is facing. This one's up, so it has a min. And I can just click on it in Desmos and it'll tell me my vertex. So what is my vertex for that function?
Y equals X plus 4.
No, so that's the actual function itself. I have clicked on the vertex on the graph. Can you tell me what it is?
Is that the -4 or -5?
Perfect, yes. So our vertex is -4, -5. So when we're comparing these functions, we're like the green and the blue, we're always going to be comparing them back to the red function. The red function is our parent function, okay? So it asks how far the graph is shifted and in what directions. Lizbeth, can you help me out with this one?
Yes.
So how far and in what directions did the green shift away from the red? So the red quadratic started out at 0, 0 with a vertex at 0, 0. And then how far did we have to transform the red function to get to the green one?
I don't know.
So we're looking at these 2 points that I've highlighted on Desmos. If I start at 0, 0, how far left do I have to go to get to my green vertex?
1.
Read the vertex. So how many units did I shift left?
-4.
Yeah, so I shift left by 4 units. Okay, so you guys would write that down. And then Lizbeth, how far did I go down to get from the red to the green?
-5.
Yes, so I'm shifting down by 5 units. Okay, guys, you should have done this last night. This is something I should be asking you a question and you should be able to answer because this should be absolutely completed. Okay, I'm gonna have to start making some parent phone calls if you guys are not completing work.
I have a question.
So for the next 2, we can notice that we don't necessarily have to graph these functions. We can just look. See, this 4 is here, the 5 is there. And so we can just kind of say the vertex and the shifts. If that makes you uncomfortable and you're still not really sure, we can go ahead and type those in. So the first one is y equals x minus 1 quantity squared plus 6. Oops. Plus 6. All right, I accidentally put a little subscript down here. Oh man. Weird. There we go. So it's the purple function, and then this last one is 3 times x plus 7 quantity squared plus 2. Okay, so the next person I need help from, Deborah, are you here? Amar, I need your help.
Yes.
Okay, so we're gonna do this function right here next, the y equals x minus 1 quantity squared plus 6. So what would the vertex be? This is the purple function on the Desmos activity, and we can highlight the vertex right here. What is it gonna be?
1 in 6.
Yeah, perfect. So my vertex is 1, 6.
Yeah.
And so if I'm comparing the red and the purple, how far did I shift right from the red?
I don't know.
So I started at 0, 0, and then I went
0,
to 1, 6. How far right did I have to go? So I'm going to get rid of these top 2. What'd you say, Amar?
0 and